Okay, good morning. Making this video here to get you guys started on the 5A notes. Um, so the first page here just talks about dilations a little bit, which we kind of talked about back in Unit 2. Um, there's a YouTube video here that I made last year that I'll link for you guys on Classroom as well, just to refamiliarize yourself with dilations if we haven't, done that already. But I want to jump down here to get these notes in for rules for triangle similarity. That way we can just have these notes down and be ready to go. Okay. So polygons that are similar. Okay. What does similar mean? Well, similar is not the same thing as congruent. Remember, congruent had, congruent corresponding sides and congruent corresponding angles. Okay. Similar is not the case. Okay. So polygons that are similar have the same shape but different size. Okay. So two things are similar. They have the same shape but different size. Okay. So, like I said a minute ago, if they're congruent, if two shapes are congruent, they have congruent corresponding sides and congruent corresponding angles. Okay. But similarity, the corresponding angles are going to be congruent. Okay, which gives us the same shape. But all sets of corresponding sides are going to be, and I'm going to put this out here, they're going to be equally proportional. Okay, they're going to be equally proportional. All right. So if we're looking at two triangles right here, just what they would look like if they were similar. Now let's say I have, these two triangles here. Let's say they're similar. Okay, so let's say this length is, this is 10 and this is 10, and this side length here is, I don't know, 15 or something like that. All right. Let's say our angle measures here are 80. I can't really do that, can I? That's a nice isosceles triangle right there. So let's say this is 80. I can do that. 80, 50, 50 or something like that. Okay. All right. So if I have a similar triangle, okay, the side lengths are going to, the corresponding side lengths are going to be congruent. So let's say I have an 80-degree angle here, 50 here, and 50 here. All right. And so let's say the triangle, which is dilated by a scale factor, of 1/2 or whatever, right? So let's say this side has a length of 5, this side has a length of 5. Well, the bottom side would have to be half of 15 as well, because 10 divided by 2 is 5, 10 divided by 2 is 5. So that bottom length would be 7.5. Okay, so these triangles would be similar because each side length is equally proportional, 10 to 5 and 10 to 5, 15 to 7.5. And the three pairs of angles, 80, 80, 50, 50, 50, 50, are congruent to each other, which fits our rule. Okay, so that's how we get shapes that are similar to each other. Okay. Now there's a couple rules, a couple shortcuts where we can determine if triangles are similar to what we did with triangle congruence. Okay, with triangle congruence, we had side, 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 and side, angle, side, and angle, side, angle, 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 side, and HL. We could also have some rules for similarity. Now we're not going to do any proofs with these, but there are some rules that can make triangles similar to each other. The first one is AA, angle, angle. So if I have two triangles where the two pairs of angles are congruent to each other, then the triangles are going to be similar. Okay, so that just means, let's say I have this triangle and this triangle right here, and let's say, I have a 40-degree angle here, and let's say this is a 70-degree angle here, and I have a 40 and a 70 in the other triangle as well. Okay, those two triangles are going to be similar to each other. Okay, that's enough information to make the triangles similar to each other, AA. Okay. The next one would be SSS, side, 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 but it's just side, side, side similarity, okay? So if I have two triangles right there, let's say I have something like this, okay, and the sides are similar. So let's say this is, I don't know, 2, 3, 4, all right? If the sides are equally proportional to each other, so let's say we multiply it by 3, right? And so we have 12, 9, and 6, okay? Those triangles would be similar as well because the sides are equally proportional to each other, 4 to 12, multiplies by 3, 2 to 6 multiplies by 3, and 3 to 9 multiplies by 3. Okay. Last one would be SAS. Okay. Side angle side similarity. Okay. Side angle side, two pairs of equally proportional sides and a congruent included angle. So if we have this triangle here, and let's say we have this triangle here. All right, so let's say this side is 6 and this side is 7. And we have an angle in here that's 20 degrees. All right. Let's say equally proportional. Let's say we multiply by 4. So this is 24. This is 28. Okay. And we have a 20-degree angle there. Okay. Those two triangles would be similar by side angle side similarity. The two sides are equally proportional. Okay, because this one is 4 times the size of that, and this one's 4 times the size of that. The angle in between them is 20 degrees. So those triangles will be congruent by similar by SAS. Okay. Now, in all these similar triangles, we got to make sure that the corresponding sides are equally proportional. Okay, that's important, and especially when we're talking about corresponding sides, because we got to make sure the sides match up. So if we're looking at these two triangles down here, you know, the 42-degree angle is between 12 and 16. So what I may want to do is redraw the two triangles here to where they kind of match up. Okay, so if I were to take this triangle here, I'll put W on top, S here, and Y on the bottom, just so that things match up, so I make sure I know which proportion to do. Okay. And so we could just sort of check these proportions to make sure. So I have 18 here, and WS is 12, and then I have 16 down there at SY. And I get to set up a proportion to see if they're similar. So 18 over 12 is equal to 12 over 16, and we'll just check to see if actually should be 18 over 12, 24 over 16. I'm sorry about that. All right, and we can cross multiply and check to see if those are similar. Okay, we'll do these similarity ones here in class. I just wanted to make sure that we kind of got these notes all set up and ready to go here. So you can watch the video on dilations if you need to, and then watch this video for 5A, and then we'll be good to go. Thank you, and have a good day.